Now let us study Faraday's experiments. Okay, Faraday's experiments have proved the electromagnetic induction. Okay, and they set the concept of electromagnetic induction. Let's see what is it. Faraday did two experiments. Okay, let's see the first one. Okay, the first experiment. So what Faraday did is he took a coil of wire. Okay, you can take coil, you can wind it over cardboard, and then connect to a galvanometer. Okay, a galvanometer is a device which will show the direction of current. Okay, here G stands for galvanometer. Okay, so G means what? It means the galvanometer. It shows the direction of current. Current, if it goes left to right, it will turn right side. Okay, if current goes towards left, it will turn left side. Okay, naturally, if you see the galvanometer, it will stand the zero position. Zeros here. Okay, in the middle position we have the zero. Okay, so let's see what happens now. So first, what happens is we have connected this coil here, and then we have connected the galvanometer. Okay, next you keep the magnet far away. Okay, there is no motion of the magnet also. The magnet is not moving. Then you can see there is no deflection there. The needle will show zero only. Next, second, what we do now, we bring the magnet fast towards the coil. Okay, I'll go here. So we push the magnet close to the coil. Then you can see the needle will turn towards the right side. There is a right side deflection. Okay, so let us see why it happens. Okay, you see that as you bring this north pole here, the north pole gives a magnetic field now. Around the magnet we have a magnetic field. Okay, so this magnetic field lines will cut this coil here. Okay, and due to this, there's a magnetic flux is there now. The magnetic flux will change. Okay, and because of that, current is produced here. Current will go from left to right. Okay, so what happens is, in this case, okay, what happens is the magnetic flux changes. Okay, the magnetic flux changes. Okay, magnetic flux we saw, that is the number of lines per unit area. Okay, so magnetic lines will change. Here in this case it's very far away. Okay, but here it must change. You know, when you push it, what happens? It will keep on be increasing. Okay, so that's why current is induced. We can say current is, we say produced. We can say it as induced current. We say okay, induced current. Okay, that happens here. So this is about the first and second pictures here. Let's go to the third one. What it shows, we'll see. Now let us study what happens in the third and the fourth pictures. Okay, so in the third picture you see here, the magnet is kept stationary inside. Okay, that means it is not moving. Okay, when it's not moving, there is no deflection. Okay, why there is no deflection is, you can see there will be magnetic field lines. Okay, but the magnetic field lines and the magnetic flux does not change there. It is not changing. Okay, so the field is not moving anywhere. It's not changing. So current is not produced in this case. Next we'll study what happens if you move the magnet away from the coil. Okay, if you move the magnet away from coil, we can see there is a left side deflection. Okay, why there is a left side deflection? Okay, you can see that around the magnet we have the magnetic field lines. Okay, so these are the field lines here. Okay, as you go away from the, as the magnet is moved away from the coil, the field lines, what happens? The magnetic flux will decrease here. Okay, in this case, what happens is the magnetic flux decreases. Okay, the magnetic flux decreases, and because the magnetic flux decrease means there's a change now. Okay, because there's a change there, a current is produced. Okay, a current is induced, let's say. But you see, the direction of current is towards the left side direction. Okay, this is about the fourth picture. Now let's go to the fifth experiment here, or fifth part in this experiment. Okay, so let's see this now. So there's a coil here, and then we have a magnet here. Okay, now what happens is, they say you move the magnet faster here. Okay, so magnet is moved faster. Okay, magnet is moved faster. What will happen? As the magnet is moved faster, you get a larger deflection. Okay, why we get larger deflection is, you can see there is a magnetic field lines here. Magnetic field lines will go here, and there's a magnetic flux also, you can say. Okay, there is an increase of magnetic field very fast. Okay, so we can say the magnetic flux changes fast. Okay, the magnetic flux changes rapidly. Okay, changes fast. You can see also rapidly, also both same way. So because the magnetic flux changes very fast, okay, you can say the rate of change of magnetic flux is fast. Rate means what? Divided by time. Okay, so magnetic flux changes there. If magnetic flux changes faster, what happens? The current also produces more. Okay, and that's why you get a larger reflection. Next we see what will happen if we keep the south pole here. Okay, if we keep south pole here, we can see we get a left side, towards left side direction. Okay, we get a left side deflection here. Okay, what happens is, if you reverse the poles, the direction of current also changes. Okay, so this is about the Faraday's first experiment.